Hello everyone, welcome to Tan45 Engineering. We are here with yet another video in our Mastering Data Structures and Algorithms in Java. Today's topic is selection sort. Let's get started. In the previous video, we covered bubble sort. If you haven't seen, please check out. So for selection sort, it is also one of the simplest sorting algorithm, just like bubble sort. It sorts an array by repeatedly finding the minimum element from the unsorted part and putting it at the beginning. So the algorithm maintains two sub-arrays within the same array. First, the left side would be the sorted array, which is built from left to right. Then the unsorted array, which is reduced one element at a time. So completely in the beginning, the given array is unsorted. So one by one, we start forming the sorted array from the left hand side. So it's a in-memory sorting algorithm. Okay. So let's go here. Let's say we have 64 25 64 25 12 22 and 11. Okay, now let's say this is our input. So what happens in selection sort is we consider that this is the minimum element. Okay, and what will happen one by one, the smallest element will start lining from this end and the unsorted array elements will be left on the right hand side. Okay, so let's jump into the understanding and then come back to this part, how we actually work with selection sort. Okay, let's get started. So how selection sort works? Okay, let's check. Let's go with the input again. Let me remove all this. Yeah, so input is 65 25 12 22 11. Of course our expected output would be in the sorted order 11 12, then we have 22 25 and 64. Okay, now let's see, there are 5 steps to solve this. Start with the first element in the array, assume it's the minimum. Okay, so we'll assume that this is the minimum. We assumed it as the minimum. Okay, second, compare this element with the next elements in the array to find the compare this element with the next elements in the array to find the actual minimum element. Okay, so what we will do is we'll compare this element with other elements and find the minimum element. So minimum element that we are going to find is 11, right? Let's go back. Once the minimum element is found, swap it with the first element of the array. Okay, so once we have found the minimum element, we'll swap it with the first element of the array, that is, this will swap with this one, so it will become 11 25 12 22 64. Okay, if you notice, from this end the array is sorted up till 11. Okay, now move to the next element and repeat the process for the remaining part of the array. Okay, so we'll move to second element. First we were at this index, so I'll mention I index starts with 0 1 2 3 4, so I was pointing to 0. Now we start with the next element, so now I will point to the second element on the first index, that is 25. We'll pick 25 and now we'll start comparing it with all the elements and we'll find the minimum element. We'll find the minimum element at 12, so we will swap them again. We will swap. Now why do we call it selection sort? Sorry, if I forgot to mention. So why it is called selection sort is, one of the thing is selection sort is one of the simplest and the easiest sorting algorithm. This is the sorting algorithm that we use naturally also when we have to sort a deck of cards, right? We find the smallest number, we put it in front. So if you look at this number by selection sort, if we, let's say we have cards in our hand, what we'll do, we'll find the smallest number, that is 11. We'll remove 11 from here, we'll put it here, 11. Okay, then we see 12, we'll remove 12 from here, we adjust in the middle of this, 12. Then we see 22, we'll insert 22 after 12. 25, insert 25 after 22, and then 64 will automatically be in the end. And this is why it is called selection sort. We select the element, so we find out the minimum element we pick that element and then we swap it. That's why it is called selection sort, plus it is easier to remember this way. Okay, so in this one we selected 12, that 12 is the minimum, we'll swap it with 25. So in the next run it became 11, 12, 25, 22, 64, right? But one thing to notice is there are two for loops that are running. First for loop is controlling our index, that one by one we are selecting the next element, like we have already selected done our sorting with the first element, that was 0. Then in this one we did with the 25, that is on the next index. In the next one we'll go to the next index, that is 2, and we have 25 here. So up until here our array is sorted. Now but when we compare the elements, so when we are comparing 25 with the rest of the elements, 25 will be compared with 12, then 12 will be compared with 22 and 64, since we found the minimum here. So we traverse the complete remaining array and find the minimum. So there is another for loop just for this traversal, and the outer for loop for running the index from which the traversal will start. So now 11, 12 is sorted. We start with 25. We compare and find the minimum. We found the minimum here. So we swap them, right? So they will be swapped and we'll get 11, 12, 22, 25, 64. Okay, so up till here the array is sorted. Now next element is 25, fourth index. So it is based on the indexes. On this indexing was 0, 0th index, first index, second index, third index, 0, 1, 2, 3, third index, 25. We'll take 25, we'll compare it with the rest of the elements, that's only 64 is left, and 25 will remain the smallest element, so no swap will take place. In the next one we'll do the same for 64 as well. Okay, now let's go back to our sheet. Okay, so continue the process until the entire array is sorted. So we completed the entire array and the final array is sorted, right? Now before I go to summary, let's go to its code. One more thing we can notice is, let's say I have a sorted array. Okay, 1, 2, 3, 4. From the selection point perspective, or I'll add few more elements, 5, 6. We take indexes 0, 1, 2, 3, 4, 5. Okay, from selection sort perspective, this is our input. We pick the first element, we start comparing it with all the elements to find the minimum. We didn't find the minimum anywhere, right? Because 1 is the minimum. So no swap takes place and we move to the next iteration. So now we'll pick 2 in the next iteration. 1, 2, 3, 4, 5, 6. We pick second. On the second index, 0th index is done. We are at the first index. 2 will be compared to 3, 4, 5, 6, and no swap will take place. Okay, so with this you can see, even if the given input array is already sorted, selection sort will run through the complete array and then confirm that it is sorted. So if you give the sorted input to the selection sort, it will still do all the computation and it will not stop just because the array is already sorted. So that differentiation selection sort cannot make, though bubble sort could make the differentiation, right? Okay, now let's go and implement this code. Okay, let's implement this piece of code. Okay, let's define our inputs here first. So what do we need for bubble selection sort? We'll take int array. What are the inputs? 64, 25, 12, 22, 11. 64, 25, 12, 22, 11. Okay, next, system.out.println original array, or not original array, let's call it sorted array, and let's print the sorted array for int item or num from array, and we'll print them system.out.print num plus some space. Okay, now before printing the array, we'll call our selection sort. So we'll say selection sort and pass our array. Okay, now our main method is here. Let's write a method for selection sort, not too many spaces. Okay, so we'll say public static void selection sort int array. Okay, so we have our input array. Now let's take the length. Int n is equal to array dot length. Now as per steps, we know we have two for loops, right? So we'll write the two for loops. For int I is equal to 0, I is less than n minus 1, I plus plus. Okay, so this is for the outer loop. Now if you notice, in the outer loop we do one pass for 64, this pass is for 25, the next element, then the third element, then the fourth element, but we don't have to do it for the fifth element, right? For fifth element we already do not have to compare, because if all these four elements are sorted, the fifth one is already sorted, right? That's why I equal to 0 till I less than n minus 1. Okay, now we'll initialize a minimum element. So we'll say find the minimum element in the unsorted array. So initialize a minimum element. Int minimum index is equal to I, that is 0th index. So we are considering that 64th is the minimum, as we discussed, right? We are considering that 64th is the minimum at the 0th index. We go through the indexes, not via number, indexes. So 0th element is the minimum, that is 64 in this case. Now we'll try to find another minimum and then swap the indexes. So we find the minimum index, or the index of the minimum element. For now int j will start from I plus 1, because if I is already at 64, when we want to compare, we'll compare it with 25 first, right? Then 25 is minimum, 25 with the next one, and next one, this way. So I is already here, j will start from I plus 1 to cover the rest of the array. So we'll say j is equal to I plus 1. J is less than n, it will go till the end, j plus plus. Okay, now if array of j is less than array of min index, that means we have found a minimum. So we'll take that index, min index is equal to j. Okay, so like in this case, when 64 was compared to 25, 25 is the minimum index, right? Then we check the other one, 12. So we updated the minimum index, that this will be our new minimum number. We compare with the next number, 12. So we made change to that, this is our minimum index. We then checked with 22, okay, this is still the minimum index. We then checked with 11 and we know this is the minimum index. So minimum index I gets, or minimum index gets updated to 4, right? So now we have found the minimum index. We'll make the swap. So we'll, at the end of second for loop, we'll say swap the found minimum element with the first element of the unsorted array. Okay, so we'll say same swapping method. Int temp is equal to array of minimum index, array of min index is equal to array of I, that is the current index of I, and then array of I is equal to temp. That's all, right? This is all that we need. And in next iteration I will move to the next, that is I equal to 1 will become. So we'll start the next iteration from first index. So earlier was from 0th index, now from first index 25 will be picked, and then it will become, then this complete array will be searched and we'll find the minimum 12. It will be swapped, then again a complete array will be searched, 22 will be found and swapped, right? So let's run it. 11, 12, 22, 25, 61. Okay, right? So that's all from actually selection sort. So in summary, the time complexity is O of n square. Of course, since there are two for loops, one inside the other, so one for loop is running and dependent on the value n. So O of n for this and O of n, another O of n for inside this. So for n cross n, O of n square. Space complexity is O of 1 because if you see, we do not require any extra memory except for this temp variable. So this is in array sorting algorithm. So pros, it is very simple and easy to implement, plus performs well on small data sets. Cons, it is quite inefficient for large data sets due to its O of n square time complexity, since we already have sorting algorithms that can sort an array in a better time complexity. So in large data sets, the time complexity would be an issue. Also, it doesn't adapt to the data, that is same number of comparisons and swaps are made regardless of the data being sorted, as we considered earlier also, right? Even if you provide a sorted array, it will perform the same number of swaps and iterations. Even if the array was unsorted, it will perform the same number of swaps and iterations. So that is one of the disadvantage. Okay, that's all from this video, everyone. If you have any question or doubts, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.